All right, Sunshine. So we're going to start on equations of parallel and perpendicular lines. So you have three forms of linear equations that we're going to work with. So standard form looks like this. AX plus BY equals C, where A, B, and C are just numbers that have meanings in other times, but we aren't going to worry about those numbers right now. In this chapter, all we do with standard form is solve for y to convert it into slope-intercept form, because slope-intercept form is the one that's more useful to us. Slope-intercept form is y equals mx plus b. So for both of these equations and for point slope form, the x and y are your variables. So that's every coordinate that's on the line, and they're always going to be x or y. They're always going to be letters in the equation. So m is your slope, b is your y intercept. Point slope form is a little bit different. So standard form and slope intercept form are the forms that I give you equations in. Point slope form is really a tool that you're going to use. You're going to go plugging things into point slope form. I'm usually not going to give you anything in point slope form. Point slope form looks a little like slope intercept form, but instead of having a y-intercept, you have a coordinate built into it. So you have y as a letter, as a variable, minus a number that's going to be the y coordinate of a point that you know that you're usually given. So x1, y1 is going to be a particular point. That's usually going to be given to you in the question. I'm going to give you a question that says, find the line that's perpendicular to blah and passes through the point 10, 8, or negative 12, comma, 476, whatever I tell you to do. And so that point is something that you can plug into point slope form. So this is going to be a variable. This is going to be a number. And on the other side of your equation, that's going to all of this is going to equal your slope. And then in parentheses, you're going to do the same thing. X the variable minus x1 the coordinate. So y and x are going to be variables. They're going to stay letters. Y1 and x1 are going to be numbers that you plug in out of the specific point that I give you and tell you the line is going to pass through that point. So now let's put that to use. So to find the equation of the lines that are parallel and perpendicular to the original, where the new line passes through the point 10, 8, so that means 10, 8 is going to be that x1, y1. So these are the numbers that we're going to plug into point slope form. And then the original line is going to pass through these 2 points. Sometimes I'll give you the equation of the line and you're going to find the slope using slope-intercept form. Sometimes I'll give you 2 points and you're going to find the slope using the slope formula like this problem. So step 1 is to find the original slope, however is appropriate for the setup of the question. So in this case, it's going to be using the slope formula. So slope equals rise over run. So that's going to be, rise is the change in y. So I'm going to subtract my y coordinates. And then run is the change in x. Remember that when you have minus a negative number, keep track of your signs. You can write it like this, or you can use parentheses. 6 minus 8 is -2. 2 minus -3 is 2 plus 3 is +5. So my original slope is -2/5. It's really important to keep track of your signs, because when we go to step 2, we're going to find our new slopes. So we have 2 questions here. We want the parallel line and the perpendicular line. So for the parallel line, it's still -2/5. For the perpendicular line, it's going to be the opposite reciprocal. Opposite means we change sign. Positive or negative. Reciprocal means we flip the fraction. So we take our fraction and we flip it upside down. So our perpendicular slope is going to be, this one's negative, so my new slope is going to be positive. And then I take my fraction and I flip it over. So 5 goes on top and 2 goes on the bottom. Step 3, now that we have those slopes, is to plug it into point slope form. So that's y minus y1. So our y coordinate in the original question, we're supposed to go through y coordinate 8. Equals the slope times, so my slope is -2/5 times x minus the x coordinate is 10. Then step 4 is solve for y. To get it into slope-intercept form. So to solve for y, we're going to distribute because we've got something times parentheses, and we don't have any parentheses, and y equals mx plus b. So I have y minus 8 equals negative 2/5 x, and then negative 2/5 times 10, negative 10, negative times the negative is positive, and then 2 times 10 is 20, divided by 5 is 4. And then I want to get rid of that 8, so I have y by itself, because y equals mx plus b has y by itself. So I have y equals negative 2/5 plus 12. And that is my answer. You're almost always going to be giving your answer in slope-intercept form. Now for the perpendicular line, we're going to do the same thing. We go back to step 3, we plug it into the equation. So it's going to look very similar, y minus, because we're going through the same point, y minus 8, but we got a different slope this time, equals 5/2 times the quantity x minus 10. And then we're going to distribute again. Y minus 8 equals 5/2x. Positive times the negative stays negative. 5 times 10 is 50, divided by 2 is 25. Add 8 to both sides. Y equals 5/2x minus 17. And there's our answer. So for the most part, this is everything. There's a couple of special cases that aren't as common, but they still come up from time to time. Your special cases are when you have x equals a number or y equals a number. X equals a number is vertical, so your slope is undefined. You remember that from first chapter? We had those properties worksheets. Much torture about undefined slopes. So perpendicular line has an undefined slope, a horizontal, or I keep saying perpendicular. A vertical line has an undefined slope. A horizontal line has a 0 slope. They're perpendicular to each other. Because if you tried to take the opposite reciprocal, obviously undefined is not a fraction. You can't take the opposite reciprocal of the word undefined. And if you tried to take the opposite reciprocal of 0 over a number, you would get a number over 0, which, you know, the world ends. You get undefined. So these guys are just perpendicular to each other. So if you have so if you're parallel, then you're going to stay x. If you're perpendicular, you're going to switch to y. If you're parallel to y, you're going to stay y. If you're perpendicular to y, you're going to switch to x. And so you're going to just get x equals a number. Whatever point you're passing through, you're going to just pull the x or y coordinate out of that. So you're going to get x equals x1 or y equals y1. So if we were using that original coordinate, 10, 8, then it would be x equals 10, y equals 8. And so there we have equations of parallel and perpendicular lines.